So welcome everyone. Thanks for joining this webinar. Good evening, good morning, good afternoon from whatever part of the world you are joining from. Thanks for showing this interest. And today's webinar topic is AI and agent technology in HVAC workflows. So the whole world is buzzing with AI, Gen AI, agentic AI, MCPs, lot of terms, right? So we wanted to bring you those topics and make it familiar. We want to remove the FOMO, fear of missing out, this AI thing, AI technology for HVAC community. So here we go. So I'll start with introducing the speakers for this session. So myself, Praveen Kumar, I am the product marketing manager at Simulation Hub. Simulation Hub, we develop AI-powered simulation platforms and applications specific to particular domain or verticals. For example, we have developed applications, CFD simulation applications for control valves and indoor building thermal comfort, HVAC simulations, and also load calculation and building energy performance. So more about that at the end. And next, with us joining Sairanvi Pawar. Sai is leading the AI and research team in Simulation Hub. She brings the knowledge of computer science, computer vision, and deep learning to apply it in the field of building performance simulation. And with us, joining our young leader, Atharva Jagta. He's a mechatronics and automation engineer, but he has a more interest towards data science, and now his work is completely focusing on bringing agentic workflows to support the sustainable solutions and in the area of built environments, high performance built environment. So next, I'll walk you through the learning objectives or agenda of this session. So we'll start with simple, introduction to AI. What is AI? What are the different terms, jargons used in this technology to make you comfortable with the terms. And then at the end of this webinar, you'll be able to answer how AI and agent technology are transforming the HVAC design and energy optimization also. Another objective will be you will be seeing what is the roles of generative AI in optimizing energy use and automating system diagnostics, etc. And at last, you will also understand the potential of AI-driven HVAC load calculation and building energy modeling to improve the productivity and make it faster and smarter simulations. So without further ado, I'll hand over the mic to Sai. Sai, over to you. You're not audible yet. Yeah.
Clear? Yeah. So, yeah, good evening, everyone. Thank you, Praveen, for setting up the right context. So we'll first start with what is actually AI, artificial intelligence. So we can consider artificial intelligence is in software or a software that has learned from some data. It is able to make some decisions, and on those decisions it will solve some problem just like we do usually. So that's AI. So if we take an example, when we open a Google Maps, it suggests the fastest route, right? So it's not only the guessing, it has learned from some traffic data, road patterns, and real-time conversation. So that's the AI for deciding based on what it has learned. So if we take an example of Netflix also, how ever wonder how Netflix knows what you will want to next watch next? That's AI. It learns from our preferences, compares them to others like you, and suggests what you are likely to enjoy. So that's artificial intelligence, if we take an example. So we can treat or think of AI like a junior engineer who's watched thousands of past projects or system runs. It learns what works, what fails, and what saves energy, and then starts helping us make those decisions faster. So this is AI. So now we'll see how it actually works. So AI works like an extremely fast junior technician. Suppose the AI system has collected some data, learns some patterns from that data, and then it makes some smarter decision. So it's not just a hard-coded logic, it's learning from behavior and acting like your most observant technician, just faster and for a whole building, not one zone. So that's how it works. If we take an example, domain specific example. So let me break this down in HVAC terms. Think about your most experienced technician, the one who walks into the plant room, glances at the gauges, listens to the fan hum, and just knows something is off. So now imagine we have taken a bit everything tech has been over the years, every temperature drift, every coil falling case, every BMS trend, and turn that into software that collects all the sensor data continuously, learns from behavior across times and systems, and make real-time decisions to help us save the energy, prevent faults, and balance loads. So that's what AI does. So in the next slide, we'll see how AI has evolved over the time. So first era is where the rule-based system works. So we have actually coded or we have written the programs followed to explicit rules written by humans. So example, if temperature is beyond 25 degrees Celsius, we have to turn on the AC. If it's a night time, then we have to fasten up the fans. So that's what the rule-based system were working. Then machine learning came into picture. So where AI has taken up some data, some historical data, and then we have trained some model on those data points. It has learned some patterns from that data, and it will predict some future things. Suppose we are using weather apps. It forecasts the temperature. It forecasts the today's weather or future weather on the historical data. Then deep learning came into picture. So it is nothing but the advanced machine learning using neural networks that mimic the brain. So how human recognizes some object, how human brain thinks if some problem comes. So that's deep learning for us. Then we are standing at the era of generative AI, where AI is not just predicting, it's generating some new content on some historical data or some trained data. So from if then rules to system that thinks, learn and adapt. So that is the evolution of era we have came through, and we are standing on the generative AI era where we are not just predicting, we are generating new contents. Like everybody knows about ChatGPT. It is not predicting something, it's writing something new for us, right? So that's the evolution over the period. So in the next slide, we'll actually see what is the AI application we can implement in HVAC. So AI can enhance heating, ventilation, and air conditioning system by just automating controls, predicting failures, optimizing energy usage in real time. So we can actually field real time data through the sensors, and it can live predict the temperatures, airflow, humidity based on some parameters like occupancy, weather, and the usage trends on that. Also, in HVAC, AI can be used in predictive maintenance also. So if some fault detection is there, some abnormality is there in components like fan, compressor, it can also predict some abnormality. Then also we can utilize AI in energy optimization also. So what sort of temperature will be needed for thermal comfort? This kind of application will be also comes under AI. So this is AI in HVAC. That's something interesting for our domain. So that's then now till here we have utilized the data what we have already, right? So what is a limitation? To predict something, we need some data. And also to train the model on that huge amount of data is resource intensive. And then it will take huge amount of time. This sort of limitation we came across. So what is the need of AI tools here? So we have till now used most of the AI tools in HVAC systems where we have optimized some operations. Also, we have used the AI to predict some failures, also to improve some comfort and efficiency. But suppose we have designed some building and the whole building architecture has been done. But what if AI plays a role before designing stage? So where AI will help what should be the correct position of air condition in that particular room or in particular zone. So that will be the shift of AI. If we shift AI approach instead of end to start, so that is a shift which we need. Yeah. So what are the new possibilities will be coming in AI in design phase? So we can predict energy loads more accurately using climate, occupancy load, and other weather conditions. Also, we can recommend optimal HVAC configuration for a building real usage pattern. Also, we can simulate control strategies before construction begins. Also, we can reduce over design. Usually we over design some systems or also underperformance from day one. So that is the new possibilities are coming in the design phases with the AI. Yeah. So buildings AI, a platform from Simulation Hub, has one feature which is the classic example of this AI application in our domain. So we have a PDF to BIM feature where the AI text reads the floor plan and it actually creates a 3D model out of it for the simulation. So we'll see the demo in picture. Yeah. Where actually it is taking a floor plan as an input, then detecting the doors, windows, and also we have introduced human in loop there, where if AI has misinterpreted some things, we can correct it. Then we can also export that particular prediction into 3D format and we can visualize that as well. Yeah, so that's what the PDF to BIM was. Yeah, so I will hand over the next presentation to Atharva to onboard all of us to this new trend of generative AI.
Thank you, Sai. Thank you for onboarding all of us with the AI as a technology. So until here, we are quite good with what AI and where it stands with the current time. So just to summarize, we have loads of data. We use that data to train some models, and then we are using those models to get some inputs or outputs. So now, if you can see, the main thing here was getting the data, and using the data we were predicting something. Now in this era we can't just wait to have the data and then do some prediction work. We should generate the data, we should generate our the things are on our own, or as a AI we should able to generate some new things. So let's see how generative AI works. So It's my privilege to welcome you guys to the world of generative AI. And from here, we'll start introducing what generative AI is and how agents are working with generative AIs. So let's first understand what generative AI is. So yes, it's a AI which is able to generate some new things. So it can create new contents for us. So usually, I believe of everyone of us at this webinar are using ChatGPT or some tools which are able to generate something, some text, some documents. So you go to the tool. So you try to do something. Let's take an example of an email. You want to write something to someone, and you are just giving some prompts and able to generate a tailored email to the person, and he is able to understand it in a well understood understandable format. So this is what is generative AI. So it needs some input, and based on those some inputs, it's able to generate whatever you want. So it's not just analyzing, it's producing for us. So at what stage generative AI stands today? So it can generate text. Again, the example of ChatGPT. You give some chat prompts, and it is able to generate something. Then images and diagrams. So far you have seen our presentations. The presentations are also made using GPTs or the chat-based interface, where we give a simple prompt that what we want to explain to the user, and it's able to generate some images and diagrams around it. So see how helpful it will be when you are trying to explain something to your client and you are not effectively able to explain it using words. Pictures are the best way of expressing. So yes, you can generate images just by prompting. Then talking about the simulation. So yes, we are domain guys and we are more concerned about simulations. So it can also generate simulation inputs for us. So it needs some prompt based inputs. So what type of simulation you want, what type of inputs you want, what type of schedules you want, and based on those conditions, it can actually generate inputs for you. If we take example of Energy Plus, it can actually generate inputs for IDF files. Other part code. So I am a software developer, and as far as I am concerned, we are concerned about codes. And yes, it's already making its way in code, and every developer or every person who is working in software industry is already using generative AI or the GPTs or Chat GPT for generating codes. So these are the things which actually are already there. So yes, I've explained you what generative AI, but why it matters for HVAC, why it matters for energy, what effect will it have on your work? So it is like I've seen you guys actually documenting your presentations or whatever the outcomes you generated from simulations, and for documenting itself, it takes hours and hours. So yes, generative AI can help you there. It can effectively draft documentations for you. If you are preparing some outputs from some simulations, it can do this autonomously. You need not to interfere, create tables, diagrams, and all, but just go to the generative AI and he will generate for you. So let's assume after you have completed your simulations, you got the documentation. Now you need to send some proposals. So all again, sending proposals in a well documented format is a tedious task. Using generative AIs, you can send proposals very effectively. That too using an automated systems. The third, the control strategies that we use while simulations. So we usually do this looking at the HVAC systems at the buildings and all. And after, so at this stage, already the systems and the buildings are already there. But using generative AIs, you just can have a way where all the strategies are already designed before the actual building or the HVAC system is being installed. The fourth thing, support decision making in early design stages. So it's not like it's way beyond you, it's with you. So it's like a co-pilot thing. As assume a plane, a pilot and a co-pilot. So you are the pilot and he will work with you to help make you smart decisions. So always our cannot focus on everything. Our cognitive load is limited. So using these type of workflows, we can actually use a co-pilot which will do small things for us, will support us, and will be able to generate a quite good effective results from what work we do. So let's see, why are we actually going from traditional AIs to generative AI. What problems we had with traditional AIs and what effect will have when we implement generative AIs into our workflows. So if you can see, there are two guys on our screen. One is representing traditional AI and one is representing generative AI. So we as a software in the professionals, when tried to get softwares built on the data which already we have, let's talk about the HVAC industry only. We found that the data is not quite labeled. And for, of course, for generating a traditional AI model or a AI model, we need data in a labeled format. It's not like you just copy and give it to the model and will be able to predict something. No, it doesn't work that way. So we need to label the data. It should be in a structured format. It should be stored in a layer wise fashion. So it's not that easy to maintain that data. And we HVAC engineers, BIM engineers have that problem. So we haven't thought in that way that yes, the data should be labeled in a very proper way. We label the data, of course, we label the data, but the way that AI understands, we are lacking behind in that. So again, uh, let's assume we have the data. The next problem is it requires months of training for a model. So it's not just having the data. So as a software industry, we need to organize the data. We need to perform some ETL operations over it. And then we, after that, doing all these operations, we need then train the models. And there are many things involved in training the models, which we face, and it's quite difficult to onboard our domain on AI. Third thing is again the extensive use of resources. Training models today still it's quite costly for us, and it is not that well when we go with using our GPUs and all to train some models. So how a generative AI approach will help us? So again, what I explained, it's not just analyzing, it can generate. So when you give a well instructed, well engineered prompt using a large language model, it will be able to answer. So let's not get into technicals, how what is a large language model. Here consider model, just a model. There is a model, AI model, which is trained over data. Again, your data. I am talking to you, you are talking to me. Internet data, it's trained over that model. And again, it's able to understand human emotions quite well, human language quite well. And using that emotions, that language, it is able to answer. So you give a small prompt, a small part of the prompt, and it is able to complete the prompt and also generate insights over your prompt. Again, the third thing, the adaptive learning. So it's not a one way thing. It's not like you give some input to the LLM models and it won't remember the things. So the good thing about it is adaptive. So however, whatever is your persona, according to it, it adjusts itself. And in the next wave, in the next part, when you will again talk to him, he will adapt himself and give answers which are more relative to you. Again, it's a context aware recommendation. So whatever questions you ask, it's not like it's only answering using the internet knowledge. So we can actually train or make the generative AIs or the LLMs context aware about us only. So let's assume we are working in some company, and yes, we require knowledge of internet whole world, but still I want to focus on my company only. Whatever work I do, I want to focus on that only. Yes, this is possible with generative AIs. We can shift from internet knowledge to a bucket of knowledge in which we need to build expertise. So these are the few things which are away or new from traditional AIs where we can implement generative AIs. So let's go to the next slide. So yes, there is a big confusion around us that yes, AIs are coming and they are replacing us. But believe me, it's not a replacement, it's an evolution. There will be new patterns of designing workflows, new ways of expressing the workflows, and new ways of simulations. So yes, let's not just get into the part FOMOs of yes, I don't know, AI will replace me one day. No, it's not and never going to happen. And we are making the workflows faster, smarter, and accessible to all the people around the world. So today, if 2% people are able to understand HVAC and are willing to apply HVAC and energy simulations, using this technology we will able to onboard 80% of people. Then 80% of people will think about HVAC. Yes, I need HVAC. I need HVAC in my office. I need efficient HVAC systems in my office. I need to make my building energy simulations efficient. And all these things will be discussed among people because they will have the knowledge of the things. So let's assume that yes, AI has been implemented, and what will be the effect of AI in building simulations or building energy simulations. So these are some consequences of AI in building energy simulations. So at this stage, we all know AI is already here. It's being implemented everywhere. And now the most important question is where I stand and what will be my responsibilities in this new world. So we'll discuss this in detail. So first thing is faster building performance modeling. So yes, we implemented AI. Earlier in a month, we were able to simulate one model, two model, three models. We used to build models. But now using this AI, we or the users are able to simulate hundreds and thousands of models in a fraction of time. So yes, now models are simulated. What to do now? So as there is a long said phrase, or we always use that with great powers great comes great responsibilities. So these are our powers, and now we need to use this responsibly. So the AI tools speed up modeling and enables the rapid design iterations. But with this, now the people are demanding for better models. So now the people are saying, yes, I want my models more efficient. So earlier, let's assume it was 20% efficient, 30% efficient. Now every stakeholder, now every user will ask you that yes, you are using this modeling softwares. You can experiment over my data on my models faster. As you took 8-10 hours to simulate something, now you can simulate it in 10-20 minutes. Now I want best results. So this is the new approach that you should use in your modeling, in your thinking. And yes, say that yes, now I want to make the models more accurate. And again, we are contributing to the society. So making things efficient will always contribute to the world in a larger manner. Again, let's take the second perspective, the bottleneck in model evaluation. So we built models, we generated thousands of models, more customers are coming, we have experimented over models, we have simulated more models. Now we have thousands of models to evaluate. So we focused on just generation. Now what to do of evaluation? Evaluation is again the next most important part in our industry. So again, this is the new opportunity where you will be using AI tools to evaluate the models which are being generated using AI. Again, AI generates something, you are using AI to evaluate something. New scopes, new energy, and new spectrum of work. The other thing which we software industry demand from is you should demand that yes, there are BIM softwares, there are simulation softwares, and AIs are implemented for generating some inputs. Now what to do with the simulations? We are still using the softwares which are 10 or 15 years before design. So there the scope where the industry people and the software people can contribute together is designing new softwares which work on these principles of AI, where the simulations will be real time. So we need not to wait for the simulations to give us some results, and on real time basis we will be able to do some things. So we need to rethink on the core simulation methods. What we do, we give simulation inputs in a 1D format, in a form like format. As far as I know, we use Energy Plus Open Studio. There is a form like format where we give some inputs. But assume where we are using digital twins, we are using some 2D data to give inputs, and we are able to simulate the simulations on real time. So these are some new domains where we can contribute as HVAC engineers or BIM engineers, and yes, we can have some effect over this industry. So let's see some opportunities in the post AI integration. So yes, again, I have explained this collaborating with AI. So using the AI tools, you can actually make buildings, design buildings faster. You can design HVAC systems faster, and that too in a effective way. So just not running after something. You can make the things effective as compared to what we used to do. Then the second thing, the evaluation part. So evaluation is also a tedious thing. You can use AIs to evaluate something. You can have your intelligence, your experience, and using that experience and using the GPTs or the AI bots as a co-pilot, you can able to evaluate what the simulation results are there. So again, talking about the skills that will be required for this, you should and you can always upgrade your skills. You need to learn how AI understands the thing, and believe me, it's not a big deal to do. You just need to go over internet, use any large language model, let's say chat GPT, and try to understand how it used, and that's it. You need not to go through long hours of courses and all. You just talk to GPTs, and it will onboard you on his own, and you will be able to use any of the softwares. So these are some kind of things we used in generative AI approach. So now let's say that yes, people are onboarded. Say people use chat GPT, and what is the next thing to do? We address that yes, generative AI is here, AI is here, it's being involved in our softwares, in our day-to-day work. So not what to do next. So let's go with an example, and let's address the problem with what the generative AI lags behind. So yes, so as far as I have discussed examples of chat GPT, you going over internet, typing some prompts, getting some inputs, this is the same way what this example illustrates. Let's see. I'll not. I'll first explain the example and then get into the software technicals of what this is called. So let's see. User is coming to ChatGPT, a AI model, and it's prompting something. What type of wall material should I use for a east facing wall in a hot climate to reduce heat gain while maintaining energy efficiency? So this is a common type of prompt which you'll go and ask to ChatGPT, and he will give you some answer. So based on this question and answer, based on this interaction, what we are able to understand, that user who is prompting has some domain understanding. He knows that not all walls will be suitable for all climates, not all walls will be suitable with respect to directions. So he knows some domain understanding, but he has not understood the deeps of domain. And here, when he comes to the chat GPT, he is expecting that. So this is what the interaction between the user and GPT is quite used like now on the internet or in the world. So people directly go to the models, ask something, they know something, they get something, but again, it's not quite good. The quality of answer is limited, and it we cannot rely on the answers. So we all have these problems. So what to do, and what mistakes we are making? So in a programmatic or a software industry, we call it as a zero shot approach. So you are just going to some person and randomly asking him something. Ki, I want some answer around this, and please answer me. So even if he's expert, he would not be able to answer it that quite effectively. He should know something, some background around it to answer you properly. So here what it lacks, here what generative AI as a technology lacks. So now we are going beyond the generative AI, and we are introducing agentic AIs in workflows. So let's onboard everyone again. So we went to traditional AIs where the models used to analyze for us. Then we went to generative AI where the model is able to generate for us. Now we have problem. It is randomly generating something, and we need to make some arrangement that yes, whatever is generated, it is good to us and it is verified, and that too in a workflow manner, not a random manner. So let's see what AI agents are now. So yes, what are agentic workflows or agent workflows? A smarter context-aware processes. Again, what I said. So the agent or the LLM will be aware of what who you are, and will be aware of a domain specific knowledge. So LLM models as a technology or a general speaking has a knowledge of internet. But again, as a person or as a company or as a professional, you always want the person to be an expert at some topic. So we'll make arrangements to make the LLM model expert to something, and that is you can understand using this technology or this approach. So basically what it is a LLM, it is a generative AI, but it's layered. It has some tools. So earlier, if we consider a real life example, LLMs were just brains. It had brain. But now when we are talking about agents, we are giving him a body, we are giving him hands, we are giving him legs. So he can actually plan, he can go somewhere, get something, he can use tools to operate over the data and do something. So this is what is a AI agent. If you can see the figure, he's waving at you. So earlier he was just a brain, now he has a body and he is able to do some tasks that you have built over it. So what are the advantages? It has higher answer quality. It can make a structured decision. If you see how structurally decisions we make, if we attend some meetings, we go through a process where a problem is solved using some aspects. We have some design rules for it. So same thing, we build a workflows around the chat GPT or LLMs, and then it's able to answer it in a structured way. Again, it's not a zero shot approach. So it will, so if you ask something, he answers you back and you say no, I am not quite good, that this answer need to be made better. So yes, again, it continuously makes improvement to itself based on your input again. And let's so after seeing all the aspects of this, we should always consider that yes, this technology is also empowering the user. So assume there are many cognitive loads that we hold while we do some task around it. So using this all structured workflow which will design at once in a while, and then in our everyday course we can able to use these workflows. Yes, so these are the some ways where a AI agent can help you and empower you. Okay, let's say that yeah, we have now introduced to AI agents, but how a AI agent is designed. So it should be not like a software industry is only designing something and there is no way of designing these kinds of workflow. So as an industry, we have also implemented some design patterns for how a agent will react to answers or react to questions and how he'll answer you. So again, it's not away from human intelligence. It's based on how we humans solve a problem. So how we look at the problem, what we do, what tools we use, and everything. And based on those principles, we have designed workflows around agents. Let's see overview of some design patterns, how they are implemented. So these are the 4 design patterns which we usually follow while designing agent: reflection, tool use, planning, and multi-agent collaboration. So let's go one by one over every design aspect and try to understand how it's implemented. So let's say reflection. So what is reflection? So you give a prompt to LLM or chat GPT, let's say, it gives you answer directly. So there is no evaluation between this. So so whenever we are trying to answer something or when we evaluate something, with rethink over it. Yes, someone has asked me some question. I am now responsible to answer him. But before giving him the final response, I should always rethink over it. We humans always do that. We always think, yes, is this the correct way? Am I not making a mistake? And everything. So this what we do is same thing we'll implement using LLM, and that is what we call reflection. So it will not just give you a vague answer. It will rethink on his own answer. He will set, there are always parameters on which we'll reevaluate our own answers, and then implement that rules over our answers, and then again give a final response. The second thing, tool use. Again, every answer I gave should be able to connect it to some softwares. Let's say you have asked LLM to generate some construction sets. So construction sets, again, a scientific property. There are U values, R values, and you decide these R and U values using some softwares, using some lab manuals, using some data. So the agent should able to have those tools, literally APIs, literally some softwares which it should be able to connect and use those softwares individually to get his answers. Talking about the construction sets, it will go to some software which is expert in designing construction sets for you. It will use that software for you without your intervention and will give you some construction sets. So that is what this tool use. Then the planning. So again, we humans do planning before any task we plan to do. So he will first make a plan in what way he should do, look over the task, and then using his own planning, he will be able to do multiple things in a sequential way. So again, it is not like limited to one agent only. So planning may involve some specialized agents. So as I said, every person or every model will always not know everything, so we'll make him professional about any aspect. So let's consider about our industry. There will be expert agent for HVAC, there will be expert agent for energy, there will be expert agent for generating reports, evaluation, everything. So every domain separately will have its own agent, own expertise built on its own domain specific intelligence, and will all these agents will collaborate with each other to do something. And to collaborate, again, it needs to make some planning, and it will use the design pattern of planning to do what first and do what at last. So these are the quite interesting part of how agents are implemented, and how what are the design principles over which all these agents are built. So now let's see some demos how actually these things are implemented. So as I addressed at the start, we HVAC engineers have always been in the problem of generating a tailored report. As reporting is the most important part of our job, and we are always spending lots and loads of time while generating some reports. So let's see how generative AI agents are able to generate reports just using prompts. Not even, it's not even like you need to do something to learn using this software. So you see how a user is interacting with the software itself, and it's the software on its own is able to onboard the users and able to help to use him. So let's see some demo. So this is buildings AI report assistant. So user is asking, I am new to this application and how can you help me? So the LLM or the agent is answering him, yes, he's good with generating some energy and load related reports, and this is the way he can help you. So again, the user is asking what type of reports can he generate. So he has said, yes, I can generate a ventilation summary and a heat load report. So again, user is asking for generating a heat load report, what kind of inputs he need to give. So the agent answered, yes, he needs a simple SQL file that we generate using a Energy Plus, and he will be able to generate the heat load report. So it took the report, it's rethinking over the reports, checking the SQL files, whether all data is present, and then processing all the data to generate a good tailored report. So this is the report that agent has generated.
So the default results coming out of Energy Plus could be, huge. The data will be huge and very unorganized. very hard to understand and process for human being. So for HVAC engineer, so there this tool comes very handy. Using the raw data, it can make a human readable, like much processable or consumable format. Yes, Athro, I can continue.
Yes. So not only reports, it can able to generate some insights for you also. So just looking at the files and the results for you, it can able to generate some graphs. So you asked for generating some graphs for getting some annual energy consumption. So agent is able to generate graphs, and now again it's customizable. You can ask him to do anything with your data, and he'll generate some good insights for you. So the era of you going to the data, looking everything again and again, and then generating some insights is gone. You just need to think what type of data I want, and it will be able to generate. So this is the demonstration of how a well engineered, a well thought report is being generated. So I'll go to the next slide. So you saw the demo, but how it works, how it works actually in the background to generate this kind of report. So let's see the background in a quite illustrative way. So this is a HVAC engineer who is first talking to the agent. So I have explained you the design principles. There are multiple agents, context agent, SQL agent, recipe agent, report agent. All these agents are collaborating with each other to give a report for you. So let's see how a user is able to interact with the agents. So the user is saying, can you generate a heat load report with only tables related to heating peak load conditions? So if you can see, the user is not only asking to generate a heat load report, he is also asking to make some changes to the normal or the defined template of generating a heat load report. So now what to do? So if you see, not only a HVAC engineer, any type of engineer. So we have introduced or used this example of heat load reports. A user from energy background, a user from any part of the world can come to a agent, your workflows, and ask anything about anything. So it is not like always that he will be using the main workflow of our software. He might be just wondering and coming to your workflows and trying to do something, but he is not aware of what is the actual power of the software or actual part of the domain that you are going through. So the context agent, what is it is designed for, it is able to understand who user is. He reads the user's inputs, builds a persona around the user's inputs, and he's able to learn, or he's able to adapt according to user. So now here he's a HVAC engineer and he's requesting for a heat load report. So the context agent has understood, yes, he's a HVAC engineer and I know what kind of reports HVAC engineer needs. So he'll now process the request and call the another agent to do whatever is required to generate or complete the request for the HVAC engineer. So what he'll do, he'll run to the SQL agent. So again, SQL files. Everyone here in his or his in her lifetime have seen SQL files. It's generated from the simulations that we perform, and it has loads of data to perform. So we go to these files, we go to HTML files, we pick out the data what we want. So what SQL agent is able to do, he has built knowledge over SQL files. He knows very well what is a SQL file and how to operate over it, and he will able to understand your SQL. So it's not like it should be on always a simulation SQL. It can come from any part of world. So it will able to understand the data, and using your data, he will be able to generate something. So again, his expertise is again limited to SQL. He should be not looking into every aspect. So he then goes to the recipe agent. What is the recipe agent? Recipe, in this context, recipe agent is able to customize users request. So he has some template. So let's consider the literal example of recipe. So we make some things, we go through some recipes to make a food item. So not always we will follow the recipe or the generalized recipe. So if we are making a pizza is always of some kind. We go with margarine cheese, we add some toppings over it, and it is fixed. So now you are saying that yes, I want some kind of pizza, but I want some customizations over it. So recipe agent is actually doing that. He's able to understand users customization. So here user is only asking for heating peak load conditions, and using that he will generate a formula for the next agent, so he could be able to generate a customized report for you. So how again how recipe agent works? I explained you about we need to make him context aware. He needs to know about the data. How it does that? So how we humans do that? How we generate reports? We follow some codes, right? We have some standard building codes which we need to make our documents compliant, and then it will be expected or expected by the client or will be used by the government officials. So how we do that? We go to the manual, we read that manual, we go to the literal rules, we follow those rules, and then generate something. So again, the same thing. Agent does the same thing. It has embed, so it's again a computer science tool. Embedding, we'll not get into embeddings, we'll just look into the aspect of embeddings. How embeddings are made? It has trained on local data, on only the domain specific data for you, and those kind of data is used by LLMs to give a good answer for you. So again, it's not giving you answers just using the internet or his own knowledge. He's answering you, he's preparing a recipe for you using a code compliant data. So this is what a recipe agent do. He builds a formula, he builds a recipe. So I need this ingredients, I need to cook this, I need to do that in our way. If we talk about our domain, I need these tables, I need these values, I need in these units, everything. He'll prepare everything and he'll send it to the report agent, so who is actually generating the report. He'll follow the instructions of recipe agent, he'll get the data from a SQL agent, he'll use his own intelligence to prepare a report for you, and it will always hand it over to the user to again validate. So it's not like, yes, you have generated some report and again I cannot make changes to it. Yes, you can always make changes to it, to again explaining the things. You read something and now I want to make some changes over it. So report agent will be able to do that using only the prompts. You need not to actually open the SQL files or the documents itself. So this is what was a report assistant, which is already implemented, and in the productionized version of our software, you can always use it, and it is able to generate heat load reports and ventilation reports for you. So this was one example. Now let's see some other agents. Now some go with some other examples where agents are actually implemented there. Let me play a video for you. So yes.
In this demo, we'll explore two intelligent AI agents, the BIM agent and the constructor agent. The BIM agent intelligently assists users in selecting and customizing building information model. It allows users to easily visualize detailed geometric and quantitative data, including critical properties such as volume, area, and many more. It enables precise selection of components based on categories and combinations such as levels, directions, and other criteria. Additionally, it leverages the material agent to deliver materials specifically tailored to the user's requirements. Next, we have the constructor agent. Its role is to automatically generate comprehensive construction sets based on user-defined criteria. Users can specify materials, define application types, and set other construction parameters to customize the generated construction sets precisely. This flexibility allows for tailored and efficient creation of detailed construction documentation, matching specific project requirements. Thank you for watching. Explore the future with AI-driven load and energy simulations, powered by Buildings AI. To learn more, reach out to us at info@simulationhub.com.
Okay. So this was some demonstration of other two agents, a material agent, a BIM agent, and of course a constructor agent. So if you have looked into the video, so in the first part where the model was interacting using a prompt, so user is writing a prompt that select something. So let's say select west side walls. So it's able to understand your prompt and it will select west side walls for you. Then you can interact with the model. Again, you can check the parameters, what are the surfaces, what is the area of the surfaces, what material are used, if it is already used in the model. And again, if it is not used, you want to assign something, you can again tell him that yes, I want to assign this material and it will do this for you. You not need to go into the form like thing, you need not to make more clicks, you need not to know about actually the every wall which is related to the direction. So anything, any combinations you can make using your prompts, and the agent is able to do that for you. The constructor agent, again, this is again a very pain for us. We generate construction sets. For generating construction sets, we need to rely on manuals, we need to rely on scientific data, and using those data we need to perform some calculations, and then we can generate a construction set. So if you have looked into the examples, you can actually just generalize, yes, I want to use concrete with this thickness, I want to use stucco with this thickness, and it is able to generate a construction set with all those u values, r values, and then use that actual construction set in your model. And believe me, it's just prompting. We need not to know any other software for this. The other part is, let's say you are just experimenting with the materials, you are operating some kind of application. If you are using let's say a office room, a gym, and you want to experiment what is the better material for this, you can just say that this is a gym floor and you can please give me a construction set for gym floor, and then it will actually generate a construction set for you using his internet as well as a domain specific knowledge. Again, let me once again repeat, whatever the data is being generated is not only based on internet or the pre-trained data that has used. So the experience that we have with chat gpt will not be here with agents. It is a well tailored and engineered data which is used in the background for his knowledge, and using that data he is actually generating the construction sets or whatever kind of workflows we do with generative ais or agents. So that was one example for you. So we saw two, three, four examples of how already agents are implemented, and these are the things which are we are autonomously or we are working currently, which you will see in some time. So we have PDFs, we have CSVs. I mean, we mean HVAC engineers and BIM engineers. We all have that data in a documents in Excel sheets and everything. So we have to go map our data and then put it into the simulations, and all this manual work is kind of very time consuming and taking lots of efforts for whatever is what we are trying to do. So where the generative ai comes into picture, all these autonomous and repetitive tasks can be eliminated just by clicks and prompts. So these are the three things we are actually working actively. So importing simulation inputs, we can use your CSV files or PDF to read the data. Again, it need not to be in a format. It can be in any format. using text and images, our models and our agents are able to understand the data and autonomously apply that data in the BIM models wherever it is required. Let's say schedules, let's say construction sets, anything. So again, the next more important thing and the most time consuming thing is zone assignment for the spaces. We follow some rules. I mean the HVAC engineers follow some rules to apply zones, make systems for the zones, and every task related to it is a lot of time consuming and effortly. So let's see how buildings AI and also the generative AI is implementing the new technology along with the domain, of course, to assign the spaces. And again, the third thing, autonomous digital twin. So now simulation results are not enough. We should always have a digital twin. So it is working on the simulations already we performed, and also on the real time data, the IoT data. So we can able to connect two things and able to make our systems more efficient. So yes, the agents are able to generate a digital twin for you without your interaction. So you need to just give your BIM models along with these simulations and all, and it will be able to generate some digital twin for you. So this is the near future where buildings AI is working, and there will be always new and newer innovations with these technologies, and we can always interact with each other. You can always reach us. Yes, I have this problem, and I can always help you. I mean the software industry, to onboard the users or the technology over it. So yes, that was all from my side. Praveen,
Yeah,
thank you. Please continue.
thanks. Thanks, Atharva. That was very informative and detailed explanation. Uh, Actually, look at the energy levels of Atharva whenever he talks about generative AI or AI agents. He often refer to agents as him, or rather than saying agent, you can talk to him, kind of thing. So he's giving some physical shape and form. I'm wondering, he might be hallucinating agents and seeing agents in real world also. So, okay. So that said, let's go to, I'll take 2 more minutes to, wind up the session. Atharva, can you go to the next slide? Okay. So I'll take this opportunity to, talk about Buildings AI application, the platform which we have developed for load calculation and energy simulation and much more. So going to the next slide. So what it is, it's an, next slide, please. So it's an agentic AI platform specific for HVAC load calculation and building energy modeling. It's powered by Energy Plus, which is the engine in the backend to do all the load and energy calculations, and powered by Autodesk Platform Services in lot of places, like, whether it is the data hub, storing the data, or visualizing the model, or cleaning up the model, building energy model. So everywhere. And AWS, this whole thing happens on the cloud platform. Yeah. Next slide. So to summarize, what we are trying to bring in Building AI is we are trying to build AI-powered human-in-loop workflows. So in every possible stage of the complete energy modeling workflow, so we are trying to bring in AI-powered human-in-loop workflows, like the one like Sai explained in the demonstration. So PDF to BIM. So even over there, it's AI powered, but wherever it misses or some review or something, human in loop is included to rule that. That kind of go hand in hand. So next slide, please. So right now, the stage of Buildings AI currently, like, we launched it in Feb, and the early access was released in May, and almost more, close to 80 to 100 users have registered and trying out different projects. And now you can go and request a demo. We'll give you early access. But even better, in another, next slide, please. So in another 10 days or so, August 12th, we are launching the commercial version of this application. So you can get a hands-on experience of this application. So that said, like stay tuned and follow our social media handles. We'll also email you with a survey to be filled. So once you fill the survey, we will provide you much, extended trial periods or benefits, especially for those who have registered and attended the webinar. So thanks for patiently waiting till the end. I know we extended a bit more time. So um, if you have any questions, like we have received a lot of questions, but we'll try to take them one by one. And so there is a question about data privacy. So Atharva or Sai, like if you would like to, whether somebody is asking, whether the my project data will it be, utilized for training for other users, or how it goes.
Okay. Yes, to answer it in a word, no. Nothing of your own or individual data will be sent out of your projects. No data will be used to train models. Again, it's in our control. Or our, in the sense, the user's control. He can always choose, okay, yes, I want to use that data for training the model, or he can always disable, yes, I don't want to contribute or share my data over the internet. So it's completely safe, it's completely over our platforms only, and the agents or the LLM that work on the data run locally, so it is not going to the internet in any ways.
Yes, rightly said. So the next question is like, can AI give me suggestions to come up with best results?
Yes. Okay, good question. Yes, of course. So as I explained in an example, it's a co-pilot. So it's not just a thing that generates anything. So it can always give you suggestions based on your inputs only, or based on whatever you have understood about the topic, or whatever you want. So you ask him something and he will always help you to do the things better. So yes, it's always context aware, it's always helping the user to make some good results out of his work.
Okay. So, how sure we are about the result or actions taken? So, how accurate is the LLM results? So, for example, I'm interpreting the question. So, for example, when we ask about some insights from the report, so the LLM, like the report assistant, showed some interpretation. So, how accurate and reliable are those results?
Okay, so let's be frank. So it's not always 100% accurate. It is learning. Today it might be 60%, 70% accurate, but it evolves. It learns from the user. User will say, yes, whatever output you have generated, it's not quite well. So if let's say today he was 60% accurate, tomorrow he will be 60% accurate, 61% accurate. As you use it more, it will be more and more accurate. So
Right.
this is the way how we interact and we develop the workflows. It's
Right.
it will just give it to you. You just need to fit it and forget it. It will do everything for you. It will adapt and learn and be better and best for you.
Yes, it's a shared responsibility kind of,
Correct.
it
Correct.
it reduces your workload and things, and then you have a review over it and then give feedback, it learns, and then continuous improvement happens. So
Correct.
great. I think there are more questions, but considering the, already we spilled out of our scheduled time, so we'll take those questions over email, and you can email to us, or we'll connect with you on your email IDs, and we'll answer those questions. So always happy to connect back and have a one-on-one call, discovery call. So please feel free to reach out to us. Thanks everyone for staying this late, and make this session very interactive. And thanks Atharva and Sai for the informative session. Thank you.
Thank you.
Thank you. Good day.
Good day.